All right, let's talk about if we had this many pennies. Let's write out what this looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? If we had this many pennies, somebody have their phone real quick. Oh, John, you have your phone out. Good for you. Google this real quick for us, would you? Population of the planet right now. Somebody else double check. Population of the planet. Should be right around 7 billion? 7.125 billion? Yeah. Let's see if I write this right. Okay, that's how many people there are on this planet. Okay, so if we had 1 mole of pennies, 1 mole of pennies, 6.02 times 10 to the 23rd pennies, and we were to say, all right, we want to take all these pennies and divide it up equally with every man, woman, and child on this planet. Let's figure this out. So, to simplify a few things, let's do this. I have 3 zeros here. I have 3 zeros here. I'm going to forget about those. Is that okay? I have 3 zeros here. I have 3 zeros here. So I'm going to forget about those. So basically, if I were to take this, see it with the bigger calculator, see if you can plug that in. You got, after the 2, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 zeros, and then divide by 7.125. It's probably going to give you something with an E in it. 8.44 times 10 to the what? Holy cow. Okay? So that's how many pennies every man, woman, and child on the planet can have right now. So let's think about this. If I make this to the 12th power, what would we be talking about then? If this is pennies, if I made that to the 12th power, what would I be talking about? What's there 100 of? 100 pennies in a? So if I went this, that's how much money every man, woman, and child could have. Wait a minute. Let's split that up. So we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Millions. $8 trillion? Because I converted it from pennies to dollars. All right? All right, well, that's fun. Yeah. I'm just saying, because you guys have heard of it, so let's talk about what Avogadro's number, how big it really is as far as pennies go. Let's see how big that is. That's how much money every man, woman, and child would have. Okay? Let's say the average person will live to be 78 years old. Can we do that? Would that sound like an okay thing? Would you believe people could live to be 78 years old? Yes, I understand some people go before that and some people go after that. But let's say the average person lives to be 78 years old. So this is how much money each man, woman, or child, and this is how long their life is. So can you take that number right there and divide by 78, please? Let's make this work for us. 1.08 times 10 to the 13. So let's convert this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's how much. Holy cow. Wait.
I got it to the 11th.
To the 11th? Okay, someone double check. We got 11th. I'm curious about that. So 8, 4, 4, 4, and then I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 0. I think 11 might be right, but double check. Lenny, did you get that? It's 11?
Yeah.
Okay, so let's ignore these. Put these back in here, 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 here. So that means, holy crow, that means, oops, I can't rewrite this. So that means that we get to spend $108 billion a year, every year of our life expectancy. Okay, so we get to spend this every year, per year. Oh boy, this is going to be fun. Okay, now let's ignore leap year. Actually, let's put it in. So let's divide this by 365.2416. That's actually how many days there are in a year if you include leap years. You're like, wait a minute, how's that work? It's every 4 years. It's every 4 years, unless we get to the end of any millennium, then you add 1. And if you get to every, and there's all these rules. I don't know why I had that number memorized. Oh, wait. Not 365.24. Oh, I'm sorry. 365.2416. Okay, so 108 billion divided by 365.2416. We got a number. Why do you got calculators, but I don't hear anything yet? Wait, I heard something. Someone's being all quiet.
2.9. I don't know.
Say it.
I don't know.
Say it.
Right. No. 2.9546854
Okay, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh boy. We get to spend that per day. Did someone else agree with that answer? Per day. And there's 24 hours in a day, so take that number, divide by 24, please. 1, 2, 3.
2061185.
Oh, so I get to spend this per day, this per hour. I don't know about you, but spending $1 billion plus an hour might be kind of a fun adventure. There are 60 minutes, so let's figure out how much we can spend per minute. So that number divided by 60.
205.
Perfect. Divide that by 60 again. Go ahead.
342239.
2192. So 22. So you get to spend $342,239.22 every second of your life if we had 1 bowl of pennies. Avogadro's number of pennies for divided amongst every man, woman, and child on this planet. Remind me to say how long. Does that mean something? That all goes the same thing with exponential. How far out? 10 to the what in meters? 10 to the negative in meters. I'd like to try spending that much money every second.
I got a different answer.
Did you?
I don't know if it's my calculator.
It might be your calculator.
Did I do?
I think it's pretty close, but we'll
I
see.
probably did.
Holy cow. Oh, and then we're going to divide by 60 one more time.
I don't think the initial answer is right. Or per day.
Oh, we got a day for on?
Yeah, that's too high.
It's too high?
Yeah,
This is what I
it's
got.
29 billion going 365 times into 108 billion.
Okay, hang on. So we're going to take 6.02. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And, oh, I got to go back. Let's just make sure. I bet you we're pretty close. And I'm going to divide that by 7,125,000,000. Okay, that gives me. Oh, you know what? We are off by a factor of 10. So this should have been a 13. This should have been an 11. This. Speak up! So we're off by a factor of 10.
Yeah, I didn't mess up.
Okay, divided by 78, divided by 365.2416, divided by 24 hours, divided by 60, divided by 60. Whoa. No. 1, 2, 3, 5, 7, 3, 5, 5.2 divided by 60 divided by 60. We are off. It comes down to 3432.60 per second. We had a math error. We're off by a factor of 100. All right, so still spending $3,400 a second. That might be okay. I'd like to try. Who's with me? Yes, sweet. All right, let's talk about the homework from last time. Again, some of you said you had some trouble on, so let's not worry about checking it off right now. I think I gave you page 408. Was this right? 1 through 20, and then 59 through 62. Was that what it was? I think that's what it was. No? That's it? Thank you. All right. So let's talk about the homework. If you have your homework, if you tried your homework, get it out. I won't mark it off today. We will mark it off next time, but let's take a look. Take a look. What do you think? 408, 408. Okay. Questions about 1 through 20? Any questions about 1 through 20? Questions about 1 through 20? If you have your phones out, please put them away, please. Please. Turn it off. 9 through 12? Okay, so number 9. Okay, we'll start here. 3 to the 5x times 9 to the x squared. Okay. Ready? Person next to you's talking, poke him in the eye. What that sticking arrow is, it's killing me. Alright, so let's figure a few things out. Let's convert everything down to base 3, because I know 27, 3, and 9 can all be put in base 3. 27 is 3 to what power? So let's convert that to 3 to the third. Are you guys still with me? And then 3 to the 5x is good to stay as is. What can I do to 9 to make it go to the third power? 3 squared. So I get 3. This is the same thing as 3 squared. And then I have, so this becomes 3 to the 2x squared power. Can we make that work? Because that was 9x, 9 to the x to the 2. So 9 is the same thing as 3 squared, so that becomes 3 to the 2x. The x is still squared, so 3 to the 2x squared. Okay? Like bases, we add the exponents, so I get 3 to the third equals 3 to the 2x squared plus 5x. So now I have like bases on either side, so the exponents are equal to each other. So if the exponents are equal to each other, I'm going to get 3 equals 2x squared plus 5x. I think this is going to be a factoring problem. I have something squared, so I'm going to bring the 3 over by subtracting it. And then let's factor it. What jury method? What two numbers multiply to give me -6? Add to give me +5. I'm going to put 2x and 2x. Factors of 6 are 1 times 6 and 2 times 3. One has to be positive, one has to be negative. Which two would work to add up to 5? The 2 and 3, but one has to be positive, one has to be negative. I think it's got to be positive 6 and negative 1. I have trash here, so that becomes x plus 3. No trash on this other one. So then I get x equals negative 3 and x equals positive half. And we got to make sure that, yeah, I think both of those are going to work because I didn't have any logarithms. I just had exponents. So I can have a negative exponent, and I can also have a fractional exponent. I like it. So that's number 9. Did you want it? Let's see. Number 10 is going to be done pretty much the same way, so I'll let you try that one. Number 11, though. Can I go to number 11? Number 11, 84 raised to the x is equal to 70. Okay? I don't think I can break 84 down to be in a same base as 70. What do you think? Like 2 to some power, is it going to be the same thing? Or 3 to some power? So if I can't break it down to the same base, the other method I'm going to use the snail method. And I'm going to write this. Oh yeah, I'm going to write this as a logarithm. So I got log base 84 of 70 is equal to x. How do I convert that? So my calculator works. Some of you might already have the base, but how would I convert that if my calculator didn't have the cool feature? There you go. Log 70 over log 84. Can somebody help me out? Do that real quick for me, please.
0.959.
Do what? 0.95? Like that? Cool. So change of base allows you to plug it into your calculator. Again, some of your calculators you might already be able to change base on. But that's how I do number 11. So if you can't convert it to the same basis, setting the exponents equal to each other, use log. Don't use natural log in this because natural log though will bring exponents down front. I guess you could do it, but it's also nice to put it in change of base form. Number 11 is going to be done the same, or 12 the same way. Any other questions? 13 as well? Okay. 13. E to the negative c is equal to 5 to the 2c. Okay. So E is standing for the exponential. So what undoes the exponential? Natural log. So I'm going to go ln. This cancels. I get negative c equals ln 5 to the 2c. Remember, natural log and log can bring the exponent down front. Is that okay? What do I want to do? I want to, I wonder if I can do this. If I just move that over, if I factor a c out of both, uh-oh. How do I solve for c? 0 divided by parentheses is? No?
0.
0. Huh. Okay. I guess. E to the 0 should be 1. 5 to the 0 should be 1. I like it. C is equal to 0. Any other questions from the homework? Up through 20. 17. Can I move off this screen? Number 17. E to the negative 0.03t is equal to 0.08. What breaks E down? ln. Okay. ln. Exponent comes down front. Those cancel. instead of 0.08. Thank you. And then divide by, that's right, ln 0.08 over negative 0.03. And then whatever that answer comes to on your calculator. I would make sure on your calculator, close parentheses there, and perhaps put that in parentheses as well when you divide them. Anything else? Good?
Can you do number 5?
Number 5. Yeah, 2 to the x equals 33. That one? Yep. What do you think?
That's what I'm asking you, dude.
So, can you get 33 in base 2? No. Okay, so let's do our shell and see what happens. So I'm going to get log base 2 of 33 equals x, and then x equals log 33 divided by log 2, and whatever that comes out to on your calculator.
Okay.
That make sense? Other things that you can see on this one, rather than doing the shell, if you do the log of both sides, then the x comes down front, you can divide by both sides by log 2. It'll be the same answer.
Okay.
Yeah. 56? Okay. 50. Do we have to do 56? 59? 59? Okay. Yeah. 59, we have this. All right, what do you think? How should we solve it? What brings exponents down front or cancels? What's going to cancel E? Shh. Cancels E. ln. So let's cancel 7.2x equals natural log 14.09. Excuse me. So x equals natural log 14.009 divided by 7.2. Whatever that comes out to on your calculator. Any others you want to see? Someone else shouted something else that night. 61? All right, 61 I'll do hit first. 61. X to the e to the 3x minus 1 equals 3. Okay, so let's start it how we might know. X e to the 3x equals 4. Is that okay so far? I'll start isolating x. So I'm going to divide each side by x. Is that okay? Then we can do natural log of both sides. So that's going to give me 3x over here. I can expand that. That's going to be ln 4 minus ln x. Now I can bring, this is a nasty problem. Jeez, who's a jerk to give this to me?
What if you square both sides by cube?
Square.
Would that cancel the natural log? And then you just swing it? Well, no.
I like it, but ooh, I gotta think on this one. I'm stuck. So I don't want to do partial fractions on it because you guys don't know how to do those yet. I gotta think on this one. I can't remember how to do it. I'm sorry. If I give you one on the test, we do it as a group. Got it?
Yeah, because there's not an ln in 3x.
Yeah, that's what I was thinking.
That would have, yeah.
Just hit it.
I can't factor an x out because ln x. I can't just pull an x out. Holy cow.
We stumped the Schwartz.
Oh man, you guys got me. Well, I got you because. Any others? So I'll hold off on that one. I'm stuck on it. 6-2, yeah. This is hard. 61. Probably.
Ew.
going to be the same thing. I got to work on these. I'm sorry, I came unprepared. Oh, dude. Oh, that.
So if we don't have them done tomorrow, when you check it, is it fine?
Yeah. All right, so let's add to this a little bit. We can do that. I think we could do that. All right. So adding to this, so I'm going to check this off tomorrow. Of course, the ones I get stumped on. So these 1 through 20, excuse me. So this is old one. And I'd say up through 1 through 20 you should be fine with. If you do the 59 through 62, you get $100,000 per second. And then let's add to this page 408, 27 through 51 odd, and that should be good. So you can continue it on the same page, you can staple it to it, but let's go with that. That should work. And then my plan for the rest of the week is tomorrow we'll deal with page 419, which we'll get to. Then Thursday and Friday we will review. The Monday after Thanksgiving, Christmas, we will finish up review, and then that Tuesday, Wednesday we'll do part 1, part 2 test. Guys and girls, I'm going to warn you on that part 1, part 2 test. There is a calculator portion that's fine, and then I'm going to have 4-function calculator, which means it adds, subtracts, multiplies, divides. So raid your parents' drawer in the kitchen. That's the catch-all for all the stuff. I bet you can find a 4-function calculator. It means you can add, subtract, multiply, divide. But that you will need one of those after Christmas. So if you don't have one, it's a great stocking stuffer. You can pick it at Target in the dollar aisle. You get 9 for $1. Okay, because they're the real cheapos, but they'll still work. Okay?